the organic chemistry tutor has a great video on this that goes more in depth than I will. But to find the common interior of this problem, the first step is to graph it. And then identify what we're trying to find, which is the common interior. And then identify the point of intersection. So it's going to be at theta equals 0 and at theta equals pi fourths. When you plug 0 into either of these, you get like a different answer, but just kind of roll with it. They made it 0 because it's at the origin, and then pi fourths, obviously sine of theta and cosine of theta meet at pi fourths because they're both root 2 over 2. So the next step is to graph them individually. So that will be our sine, and that will be our cosine. And then plot out your point of intersection. And then this is where I had been messing up, because I did all of my integrals from 0 to pi fourths. But if you take the integral of cosine from 0 to pi fourths, you're going to get all of this, like this whole top half of the circle, and you're going to get an answer that's too large. So instead what we do is we take the integral from pi fourths to pi halves. And that will get us only the part of the circle that we want to, which if we look back on this graph, that will get us this top half of the like intersection, the interior. And then for sine of theta, we can do 0 to pi fourths, because in this whole area, we're only going to get this. And this bottom half is going to match up nicely and fill in the other bottom half. So then we add those integrals together, 0 to pi halves. You do pi fourths. 1 half of r squared, which will just be cosine squared theta d theta, plus a half of the integral, and sine is 0 to pi fourths of sine squared theta d theta. And then from there you just do some angle identity crap, all that, and you get your answer. I'm not solving that out because I do not have time, but I hope that makes a little bit more sense because it helped me a lot.